Polar bonds seen in covalent compounds. Covalent compounds could be further divided into polar covalent compounds or non-polar covalent compounds. Let us first see the non-polar covalent compounds. Non-polar covalent bonds have a symmetrical charge distribution. To be a non-polar bond, the two atoms involved in the bond must be of the same element to share equally. Some examples of non-polar bond are hydrogen or nitrogen. Non-polar covalent bonds, when both the atoms pull the electrons equally, the electrons are shared equally. This happens when both the atoms are the same, like in the molecules of hydrogen, oxygen, nitrogen, chlorine, fluorine, bromine, and iodine. It also happens when both the atoms have very similar electronegativity values, like CH or CC bonds, methane. Let us see the structure for methane. In methane, there is a central carbon atom which is pulled by hydrogen atoms from all the four sides with an equal pull, and hence there is no polarity, so this is called as a non-polar bond. There is also a non-polar covalent bond, as we are seeing in the structure of hydrogen here. It's not polarized because there is the same charge on both the nuclei and electrons spend equal time near each nucleus. Now let us see polar covalent bonds. Covalent bonds can have an ionic character. They can behave like ionic bonds, that is, if they are of unequal size. Bonding of electrons attracted more strongly by one atom than the other, then the electron distribution between them is not symmetrical. This is seen in case of hydrogen chloride, HCl. Hydrogen has a delta positive charge, whereas chlorine gets a delta negative charge. So, although the electrons are shared between hydrogen and chlorine, chlorine has an extra pull, having a higher electronegativity. Chlorine has an extra pull towards these electrons, giving it a delta negative charge. So, such a bonding is called as a polar bond. Polar covalent bond seen in the water molecule. In water molecule, we have an oxygen atom and two hydrogen atoms. The oxygen atom, having a larger size, has a higher electronegativity and hence has more pull towards the electron. The electrons are pulled towards oxygen and oxygen has a delta negative charge, whereas the hydrogen atoms have a delta positive charge as the electrons are pulled a slightly more towards the oxygen atom. So this is the polar covalent bond in water, and hence water is also called as a polar solvent. Now let's recap all the bonds that we have studied so far. So we have seen the non-polar covalent bond. It's one of the most common bond. It is found in diatomic molecules like chlorine, fluorine, iodine, bromine, hydrogen, nitrogen, etc. Polar covalent bond, where we see examples like HCl or water, where one atom is of a different electronegativity value than the other. One has to have a more electron affinity or more electron negativity, and that is why the electrons are slightly pulled towards that. So that is a polar covalent bond. And we have ionic bond in that complete transfer of electrons take place.